All right, so let's get into sections 4 and 5 here. This is just algebra application of our types of angles formed by parallel, line, and transversal. Um, this is basically we have two criteria. We have congruent. Sorry, that doesn't look. And then we have what we call supplementary. Change to equal 180. The ones that are congruent are your alternate interior, your alternate exterior, and I ran out of room, so I'm gonna come over here, your corresponding. Okay, alternate interior, alternate exterior, corresponding. Our type that are supplementary, formed with the parallel line and transversal, are basically our same side interior, or consecutive interior, and same side exterior, or consecutive exterior. So what you're going to have to do is you have to identify the type that's being used to help you write the equation for x and then solve it. So in our example here on the 24, they tell us t is parallel to w, which means we're going to have two different transversals. We have this transversal here, and I'm just going to get a different color, and this transversal here. So this is going to be a multi-step problem. Right now, none of these angles have a special type of relationship. Because if I look at angle, this 5x, this is made with the two transversals. It's not even made with the parallel lines. I want the angle to be made with the parallel lines. So to be made with the parallel lines, it needs to go with the t and the transversal. This 2x is made with the yellow transversal and the line t. So that's made with the parallel and transversal. But over here, it's on the outside. This is inside. So what I'm going to need to do is recognize I can use vertical angles right here, which means they're congruent, which means this 5x plus 40 is now in between the parallel lines. And really, excuse for this little marking here, really, this is now showing same side interior. So whenever I have same side interior angles, they are supplementary. They're equal 180. So now I can set up an equation here using, let's get my pencil so you can see what I'm referring to, using this 2x and this 5x plus 40. So I would set this up as 5x plus 40 plus the 2x equals 180. And then we're combining our like terms. We have like terms with the x's, so 7x plus 40 equals 180. And now we're solving for x. Okay, so I do want you just find the value of x. So let's see if we can finish this. Now when you get to this section, for all of these three problems here, they're going to use the same diagram. And in this diagram, the horizontal lines are parallel because of the arrow. And we have only one transversal. So now, if you want, you could use your color coding here because there's only one transversal. Remember, anything with the same color would be congruent, different colors, supplementary. So I'm just going to see if we can recognize the angle type, the pair, the relationship, so we can set up the equation. So here on 25, we're focusing on 2 and 7. They're not on the same side of the transversal, they're on opposite sides. So we call that alternating or alternate, and they're outside the parallel line, so they're alternate exterior angles. And those relationships are congruent. So that's your hint to set up this equation. We have to make our two expressions, the 4x minus 7, equal to each other. 3x plus 4. So we are doing two things now. We are finding the value of x and the measure of the angle. So you need to solve for x, eliminate your smallest variable first. Okay, so we get x minus 7 equals 4. And then we're going to add the 7 to both sides. So our value of x is 11. Now to find the measure angle 5, 5 is green, where it's not the same measure of, it's a different color. So if I plug it into, it doesn't matter, 2 or 7, got to plug into one of the given ones. So if I plug it into the measure of angle 2, then that means I'm doing 4 parentheses 11 minus 7. That's 44. Then we're doing 44 minus our 7. That's our angle 2, but we're going to use that to find our angle 5. Because this is our 40, I'm sorry, not 40. This is our 37 here. So if angle 2 is 37, that doesn't even look like 37, sorry, which is the same thing as angle 7. Well, 7 and 5 are a linear pair. So I have to do 180 minus the 37, and that would give us our measure of our angle. Okay, so 143. Now, this is basically what we're doing for the remaining problems. We want to know the angle relationship. So on 26, we're looking at 3 and 7. 3 and 7 are corresponding angles. And corresponding angles are congruent. Again, the equations are going to equal. We're doing a whole different value of x here. Plug it in, then solve for angle 2. So I do want you to try to complete these. We have plenty of examples in our spiral to help you with that. And then our last section here, I'm going to go to the last page here. Now we're proving, this was our last green foldable we did in class. You are given information, you have to determine which lines are going to be parallel, state the converse to justify. So to do this, this is when there was 5 ways to prove, okay? Alternate interior, angle theorem, the alternate exterior, the corresponding. We needed these angles. If we see the angles, we need them to show they're congruent to use the converse. And then over here, if we see same side interior and same side exterior, we need these to be supplementary, which means they have to equal 180 to prove lines are parallel. So basically, you're going to look at the given angles. See here, they give us angle 8 and angle 20. Well, that means N is the transversal. That's the line they share. So I look at the relationship with that transversal. Well, they're alternating, and they would be in between lines X and Z. So that would mean, since the angles are congruent, and I'm showing alternate interior angles congruent, then I can say X is parallel to Z. Well, here I'm looking at angle 1 and angle 9. Those are corresponding, and they're showing they're congruent with that symbol right there. But because I see corresponding angles congruent using this transversal, which lines have to be the parallel? This would be X is parallel to Y. So this is what we're doing. This was kind of in our notes and part of some of our practice that we did. When you get to supplementary equals 180, I'm going to jump to number E here. They're looking at 6 and 24. We got to make sure they have a transversal shared line, even to go to green, even to see the relationship. So here's 6 and here's 24. The transversal's in, and those two are same side exterior. So that would work. Okay. So I can see if the ends of transversal, the lines that make the angle are X and Z. So X has to be parallel to Z using same side exterior angles equal 180, our supplementary. Okay, so try to determine which lines are parallel. And then the last section here, which value would make the lines parallel. So if I look at the angles again, I'm looking at alternate interior. And so I would have to use the alternate interior angle theorem, angles theorem, showing congruent to now solve for X. So I would set this up as 14X, sorry, minus 25 equals 129, and then I can solve for X. All right, so please finish this. Don't forget you do have posted on Teams some flashcards to help you study, and also there's a reminder. Oh, it's not showing here, but you also have extra credit on quizzes. All right, thank you.